All right. Hello, everyone. Welcome. My name is Bo. We're really excited to have you here for Innovations in Building Products and Technologies. I'm going to give folks a few minutes to trickle in since we're still at 59 here. But then I'll jump in and start to tell you a bit about Acelab. We're the host of today's event, introduce our guests, and we'll get started with today's presentations. Let's see, looks like we've got some folks joining already. Hello, everyone. Welcome. All right, I'll go ahead and jump in. So, hi, everyone. Welcome to Innovations in Building Products and Technologies. This is the second edition in this series that Acelab is hosting, and it's really focused on bringing you, the most interesting and innovative solutions that our team of architects and product experts encounter. So we're really excited for these three guests today. We have Jessica McNaughton from Green, Aurimas Sabulis from Dextall. He's going to be joining us in just a bit. He's going to be our last presenter today, and Tobe Sheldon from BAMCore. And again, my name is Bo. I'm an architectural product specialist at Acelab. Acelab is the host of today's event. Here's a snapshot of the rest of our team. We are a startup founded by architects for architects and building professionals to be able to experience the product research specification workflows in a lot more seamless fashion. So our vision was to, start building the work tools that we all wanted ourselves in practice. This is a kind of quick diagram of, the experience that we are working to streamline. So, product research and getting in touch with the right experts can often feel really disjointed. It can be hard to get the information you need when you need it. And then it can be hard to find, save, and organize all of that stuff in one centralized place. So that's why we built Acelab, and I will jump over to show you our live platform. Here's our site. You can sign in. Our sign-in process and login process is really simple. So it's quick and totally free to make an account. Our platform is completely free to use for architects and builders. Once I sign in, I'm brought to my library. So I've got this quick dashboard view where I can just really easily pick up to all of the product research I've been doing throughout Acelab. So whether it's searches that I've saved, products that I've saved, conversations that I'm having directly in the platform, or projects that I've uploaded, I can get a quick snapshot of all of my data here. And first, I'll just jump in to show you all of the stuff on Acelab that's like your world. So your library is over here on the top right. First, I'll show you my project portal. This is really kind of a flexible system. So you can see I've added some projects as residences. I've also added a firm standards and general research folder. So you can really make this, platform work for you, however is best to, organize your research that you're doing. Adding new projects, again, super simple. So, we don't want anything to take too much time up front. You can always come back and add more project information, but we only ever ask you 4 questions to upload that project. Once I do that, it's over here, and I'll jump back to one of my other projects to show you one that has a bit more info. So here's my general research folder. You can see over here in project info, we have the ability to store documents. You can upload drawing files, so you can really store a lot of your project information here. And the great part about it is that it is all connected to your product library. So anytime you find and save a product on Acelab, it will be tagged here with your project if you've saved it to a project. So when I go to my general product library, I can really quickly get an overview of all of the products that I've saved, which projects I've saved them to. If I've saved them in multiple places, I'll get a snapshot of that. And I can also filter this by product category. And then we also have the ability to have conversations directly with our reps in the site. So you can connect directly and get more product information. Anytime you connect with someone, your project details will be saved here, so you don't have to continuously repeat yourself over and over. You can also send attachments back and forth directly through the site. So all of those drawings and project information that you're storing through your project portal, you can also use to communicate with reps and to be able to get to the answers that you need. And then the last thing I'll show you, which is the most exciting part about this whole thing, is the ability to search for products. So heading over to my searches. Here are searches that I've saved, again, filterable by category. I can also give them, specific names so that I can always remember what I'm looking into. And if I haven't started a search, I can really easily come here to start a new one. So just to kind of quickly give you an overview of our search tools, our search tools are all really visually guided graphic processes. So we've got great diagrams. It's really a visual process to be able to like look through our product data categories. We always ask for your location so that you can make sure that you're getting in touch with people who will be able to service your area. And then another thing I like to point out is that anytime you see one of these little question marks, we try to provide as much information as we can. So whether that's, information about how energy performance might affect your R values, or how, a material might affect costs, you can always hover over these to get a little bit more information on what these filters might mean. And then from this results page, you can always come up here and change up your answers. So you don't have to go through, the whole quiz process every time. I can save this search. And I can either save everything to a project or to general locations. So I've saved this to my project. And then I can come over here and see my searches under my project. All right, and then there's just like a few more hidden things that I'll show you all while we're here, and then I'll hand it over to our next guest. But I also just like to show that we have a construction details library hidden over here in the resources at the bottom. So our construction details library is a great place to come and get some inspiration, just get some drawings that you can use to be able to kind of figure out your own details as well. And then the last thing that I'll show you down here are our building science courses. So if you haven't seen these yet, we have a bunch of AIA approved credited courses on our site. These are all worth $0.25 of an LU, and you can come over here, watch these anytime on your own time, and rack up credits for them. So yeah, that is my quick tour of Acelab. And with that, I will begin handing it over to our first guest. So first, we're going to hear today from Jessica McNaughton from Carrigreen, and then we'll be moving to Tobe Sheldon from BAMCore, and finally Aurimas Sabulis from Dextall, who will be joining in a bit. Each presenter will have about 10 minutes, and then we will also leave 10 to 15 minutes for questions and for audience engagement at the end. If you have questions throughout the presentations, please feel free to enter them into the Q&A chat. If we have a little extra time after each guest's talk, then we might pause and answer a few questions there as well. So feel free to send in your questions throughout the presentations. And one last thing I just remembered that I'm going to send over to you all on the chat. If you missed the beginning of the demo or you'd like to find out more about Acelab, we hold weekly info sessions, so you can register for one of those at this link. They're a lot of fun. We, answer any questions live. We can talk through product research questions, all of that good stuff. So, all right, that's it for me. And now, Jessica McNaughton, if you'd like to take over and begin your presentation about Carrigreen.
Sure. I'm going to share my screen here. Tell me when you can see that.
Yep.
Okay, great. So I'm going to quickly just tell you a little bit about Carrigreen, and then I'm going to get into more detail about one of our products, but I just kind of want to set the stage for who we are. We're based in Raleigh, North Carolina, and our mission is really to bring better building materials to the market. So we want to make sustainable alternatives available and give you a sustainable alternative to a conventional building material. We want to identify the best, the materials that have the best story, that's true, that's not greenwashing. So kind of vetting all of those materials and bringing the, kind of curating the whole collection and bringing the best to market. We educate a lot, so we don't want the wrong product in the wrong application, which is why we appreciate, platforms like Acelab. You described that little question mark, but that little question mark really can keep someone from making a huge mistake. So we're educators in our materials. We are technical experts as well. And then, we just, at the end of the day, our mission is just to enable everyone to be able to work, live in healthier spaces. So we have criteria for the products that we choose. They have to have a green sustainability story, be healthier alternatives, and be transparent. So transparent is a big one. You can't optimize your product and be better until you're transparent about what's in it. So we work with the brands that we distribute and represent. in getting them the right transparency documents, giving them the right information on, which platforms they should be on, which documents they need. So we don't just warehouse material and then shove it out the door. We really kind of build the whole ecosystem around that product so it can go to market. These are the brands that we carry. There's a lot of interior finishes here as well as some exterior products. Recycled glass, recycled plastic, thermally modified wood, recycled paper composite, cork, acoustic panels, and sintered stone. In sintered stone, the version that we carry is Lapitech, and that's what I'm going to dig into a little bit here. So Lapitech is a sintered stone. If you don't know what sintered stone is, we'll kind of walk through a little bit of that in a minute. But the main thing with Lapitech is the existing materials that are on the market are stone and quartz. And the limitations that those materials have is oftentimes, for quartz, certainly, it cannot be used outside. It has a resin in it that will turn yellow. They have high levels of crystalline silica, and we'll talk about why that's a big deal in a minute. They can also stain or etch. They're mined, which can often be an unchecked process. In different parts of the world, mining can be very dangerous for the community it happens in. Stone has to be sealed annually. And so there's all these things that were kind of issues on the market. So it wasn't, quartz and stone weren't the perfect material. And Breton is the company in Italy that made the equipment that quartz is manufactured on. So they make all the equipment that you fabricate stone and quartz and, either the manufacturing process or, cutting and finishing those types of materials. So they saw these shortcomings because they're earlier in the supply chain. So they created a new production line for sintered stone to specifically improve on the shortcomings of quartz and stone. So what they initially took this technology and they went to the market and said, hey, who wants to put in these production lines? But the manufacturer said, no, we want to stick with quartz. That's our bread and butter. That's our moneymaker. So Breton decided to come up with its own brand of sintered stone, and that is Lapitech. So Lapid meaning stone and tech meaning technology. So basically what they call it is geology in a factory. And I've been to this factory and it's fascinating. They take 100% pure minerals. They underground compact them using vibrocompression under vacuum. Then they run them through a kiln and cool them and finish them. And there is nothing in that material except 100% natural minerals. So that's why I liken it that, geology in a factory is kind of like, it's like igneous rock formation. So some facts about Lapitech sintered stone. It was created and patented by Breton. It's used for countertops, flooring, and cladding. And it's designed to address the shortcomings of stone and quartz. So it really is the what's next, right? So it's kind of the keep up with the Joneses. Sintered stone is the Joneses. It's UV stain, scratch, heat, and freeze resistant, which is why it's able to be used outside. It's why it's, they have an induction element that works specifically with it through the material. Again, 100% minerals. That means there's no resins in it, which means there's no petroleum-based materials in it. And it's 100% crystalline silica free. And these two characteristics of Lapitech are the performance is better, but it's also a healthier option, not only for the homeowner, because you don't have these resins and it's just minerals, or the office space or the hotel or the hospital. It's safer for the people that mine it, it's safer for the people that cut it, and it's safer for the people that are installing it, because they're not going to get this airborne crystalline silica. And that's the problem that the industry is facing. And this is a tidal wave and it's coming very quickly. This is all headlines within the past week. They refer to it as the new asbestos. They are working now on banning engineered stone, quartz, in Australia. It passed the first step of legislation yesterday. But basically what happens is when this material is cut, quartz and stone, this dust that becomes airborne has crystalline silica in it. Those are like little, I liken them to like ninja throwing stars. They get in your lungs and they slice it up and create these little cuts. Those cuts heal and it's scar tissue. And eventually you can't breathe. There's different types. There's chronic silicosis, acute silicosis. It can be rapidly onset. It can be a long-term thing. But for years, people have been cutting material without the proper equipment. There is a very safe way to install and cut quartz and stone, but the fear is there's a lot of litigation that could be potentially coming around this. And there's a lot of people that sit in a driveway, and we've all seen them. There's two sawhorses and some guy's cutting tile and he doesn't have a mask on. It's dangerous and it shouldn't be allowed. And a lot of OSHA requirements are really honing in on this. So this is an industry problem, and Lapitech and Breton specifically, who was very heavy in the quartz market, said we need a better solution. So Lapitech is now silica free. So this is basically a man-made stone with zero crystalline silica in it. They patented their own mix called Biorite, which is 100% crystalline silica free. So it's not going to cause silicosis, which is that incurable lung disease, and it's safer for everyone involved. So there are other sintered stones. They are not silica free yet. I hope everyone's going that direction. I know that Breton has a line of products called BioQuartz, which is crystalline silica free quartz. So the industry is moving in that direction. It's just that Lapitech kind of started there. So it outperforms quartz and stone. It's not considered a commodity. It has superior aesthetics throughout the slab. So the difference between, some people liken sintered stone to porcelain. The difference is Lapitech sintered stone has veining that goes all the way through the slab. Porcelain, it's printed on top. So when you cut it, you have a pure white edge and then this pattern on the top, and it kind of looks wonky. So Lapitech as a company is committed to environmental health through 100% mineral composition and no resins. It's also silica free, demonstrating their commitment to human health. So that's my presentation today. I wanted to talk about something that's very relevant to the industry and everyone in it, not just the end customer. There really is a lot of impacts along the way, and CareGreen as a business, we really spend a lot of time with the partners and the brands that we partner with to make sure that we believe they're doing the right thing, like Lapitech is here.
Awesome. Thank you so much, Jessica. I'll just pause here real quick. If anyone has a question for Jessica now, we do have an extra minute or so. So you can feel free to enter that in the chat. If not, we'll get to them at the end. And Toby, you'll be next. So you can feel free to start sharing your screen whenever you're ready.
Okay, I'm going to turn off my video because I'm experiencing a little bit of bandwidth problem out here in the Appalachia Hills.
Cool. One.
Okay, so my name is Tobe Sheldon, and I'm from BAMCore. And in market, we have what we call the Primal, which is the high performance, beyond zero carbon footprint, low-rise framing system for both commercial and residential construction. We'll go over a brief history of BAMCore. We're going to compare the carbon footprint of some common framing methods versus BAMCore's framing method, learn a little bit more about the high performance BAMCore Primal framing system, and then also review the benefits of changing the materials and methods of building today, which is, I think, why we're all here. BAMCore began in 2008. There's a framer in Sonoma County by the name of William McDonald, and he was getting very disgusted with the quality of the wood timber that he was getting in 2008 because it wasn't really mature enough. It was young, so the strength qualities weren't as good. And then he would put up a beautiful job of framing, and then the MEP would come in and drill holes and knock things around, and it would degrade the strength of the framing that he'd put in. So he thought, wow, wouldn't it be great if we could eliminate some of these studs and have more of a hollow wall system. But how to do that, because plywood, of course, would not be strong enough to hold up the structure. And in his discussion over a beer, somebody mentioned that he should check out timber bamboo. And he did, not being a scientist. He had to employ the help of some other people, but he started in his garage just sort of experimenting with this concept. And how BAMCore got its name is originally, on the lower picture here, we see the Generation 1 BAMCore Primal. We had plywood on the outside and then bamboo on the inside for the strength. We put the plywood on the outside so that framers would be using something that looked familiar to them, so it would be easier for them to adopt. In 2018, Hal Hinkle was introduced to Bamcor when he was looking to build a home in Sonoma County. And he was so inspired by the possibilities of using timber bamboo that he came out of retirement to lead us into a carbon negative future. So Bamcor today is dedicated to decarbonizing the built environment by harnessing the best of nature and technology. This photo on the right is our crew in a fairly young timber bamboo plantation. It's about 7 years old, which is when we can start harvesting culms every year. So I think it's a great photo because you get to really see how fast they grow and how big they get, and they just continue to get bigger and grow faster the more they're harvested. So we utilize regenerative fast-growing timber bamboo, and we are starting to incorporate eucalyptus as well. And we continue to innovate in the space with new industrialized construction techniques and 3D design bid build to reduce waste, carbon, cost, and labor. We have so far 22 patents issued and more patents pending. So building materials and methods account for 40% of global greenhouse gases. And it's really up to us to start making wise decisions for our future. We're kind of running out of time. And this pie chart, I think most people have seen, but this is our annual global carbon emitters by sector. And building materials amounts for 12%, building operations for 28%. So the materials, the high embodied carbon is everything that is emitted before we even start to use the structure. And that's all carbon that we can't get back. Operating emissions is what's happening every year, but efficiencies, we can continue to improve and upgrade and lower that percentage. We'll never lower the high embodied carbon of a building once it's built. So we're just beginning to understand carbon parity and time value. And what this means is if you build an energy efficient building but you use really high embodied carbon materials to do that, you're never going to get to net zero because you started at such a deficit. And so we employed green technology solutions to do a comparison of a building with the prime wall, the same building using wood, the same using brick, and the same using concrete. The completed Bamcor building has captured and is storing the most amount of atmospheric carbon. Wood is storing some carbon, and brick and concrete have emitted a lot of carbon. So we only get one chance to choose our building frame. So it's really important to be thoughtful about this when we're designing our buildings. The time value of carbon capture is not reflected in this table. And what I mean by this is that timber bamboo captures the same amount of carbon every year of that culm that you cut down. It takes 1 year to recapture that carbon again, whereas it takes 25 to 75 years for a tree to regrow and capture the same carbon of a tree that you cut down. Also, just taking a quick look at operational carbon for a present value of 50 years. Bamcor is more thermally efficient for the same building that we were looking at for the embodied carbon, and saves about 6.4 more tons per year. So looking at changing the materials, and why we're looking at bamboo and eucalyptus is because they are extremely fast growing and they are regenerative. Also, their structural properties are 25 to 90% greater than wood timber. Also, timber bamboo helps reclaim degraded lands and bring back biodiversity to the ecosystem. So we did a very extensive study that came out in 2019, carbon farming with timber bamboo. And this just kind of shows, this graph here shows how much carbon timber bamboo captures with versus wood over 20 years in the same amount of land space. But timber bamboo only needs 1/5 of the land space to grow the same amount of fiber as you would need with wood timber. We're just getting some of these same studies done with eucalyptus to show how well eucalyptus does as well. But timber bamboo, we know, captures 4 to 5 times more carbon than wood, atmospheric carbon, than wood timber does. So the construction industry has these pain points. We have labor shortages, sorry. And how BAMCore is solving that is our method is extremely easy to install with just a nail gun. And so it allows you to employ less skilled workers, more novice workers, because we have a skilled worker labor shortage. There's also slow construction cycles, and we solve that as well by increasing installation speed by 50%. Material shortages, we've kind of gone over that with, we've started the first global supply chain of timber bamboo. In changing the method, we're using industrialized construction techniques. We found that when you are doing prefabrication, a lot of the waste that you are saving from happening on the job site was being translated into the factory. So we developed nesting routines to eliminate waste in the factory as well. And we have recently integrated a materials carbon calculator, which gives owners the tools to make sustainable choices during the design phase. So this means they can play around with what different materials and designs they want to use and see what that carbon footprint would be. So again, the BAMCore Prime Wall, we are a high performance commercial and residential low rise framing system to save you carbon cost, time, and labor. This is a multifamily development in Utah. So here you have a good look at the BAMCore Prime Wall panels. You can get a sense of this empty cavity that we are creating by eliminating 90% of the studs, headers, and posts. They arrive at the job site with precision cut, millimeter accuracy for every opening, outlet, door, window, access panel. MEP lines are drawn directly onto the panel, as well as a nail pattern, and they're palletized and sequentially numbered. So you can pull the first panel to set, and then the next comes with it. They go together with kind of a shiplap design. So there's two colors of nail patterns for the different size nails. And so you could really just, your novice workers can go along and hit one with one nail gun for one color and the other with another nail gun for the other color. So with 3 people, 1 skilled worker, 2 novice worker, you can erect a BAMCore building in half the time of 2x6 with half the crew. So here we see again, just comparing to a conventional 2x6, where we reduce or eliminate OSB and gypsum board, and we also eliminate toxic rigid exterior foam sheathing. So just to give an idea of this empty insulation cavity, that also has eliminated 90% of the members that would cause thermal bridging. And so more numbers on our performance versus conventional 2x6. We're 51% stronger. We can stop a small caliber bullet. The whole wall acts as a stud, which really opens up your design freedom as an architect, but also it helps speed construction because it's much easier to hang cabinetry. We have a 50% improved thermal performance if you're using the same insulation with BAMCore as a conventional 2x6, because we don't have those thermal bridges. And again, a 50% improved acoustic dampening. And our extreme energy efficiency, Qantas did a preliminary LCA in 2020, which said that a BAMCore home saves 223 megatons of CO2 per house equivalent. Again, faster and easier to install, half the crew, no cranes, reduces waste, saves time and money. And the numbered panels, nail patterns, MEP lines, opens up the labor pool to less skilled workers. It's really helps the trades as well. Putting in plumbing and electrical is super easy because they don't have to be threading through those cross members. So in conclusion, The benefits of changing your building materials and methods include mitigating the housing crisis and labor shortage crisis, because you can build stronger and faster. You can reduce waste and cost. You can open the labor pool to less skilled workers by using fast-growing renewable materials. We mitigate the climate crisis by eliminating the use of high embodied carbon materials, carbon and store atmospheric carbon and durable carbon negative products, drastically reduce operating emissions. And we get to, this is really cool, also mitigate poverty in the global South, because where the cultivation of timber bamboo reclaims degraded lands, and where it's primarily grown is in the global South. And the planting, management, harvest, and slat production, we rely heavily on the knowledge of the indigenous people. And we've built really great relationships with them. And except for harvest, everything is primarily done by women, which I think is very interesting. And if we have 60 seconds, I'll give you, or not 60 seconds, 10 seconds. This is a really quick video just to give an idea of pulling it all together. And that's it in a nutshell.
Awesome. Thank you so much, Toby. That was really great. Yeah, very relevant topic. Our next speaker will be Aurimas Sabulis from Dextall. So Aurima, whenever you're ready, you can go ahead and share your screen. Again, feel free to type in any questions. I see that Jessica answered someone's earlier, but yeah, if you have any for Toby, feel free to type them in now. We can start answering some of those before the end. And we'll also leave 10 minutes at the end there. And oh, one more thing, I will also put up a poll before the end of today's webinar, so that if you want to connect with any of our guest speakers, learn some more about their product lines, or if you have any current projects that you'd like to talk to them about, you can answer yes on that poll, and we'll take care of getting you in touch with someone. All right, Aurimas, feel free to get started whenever you're ready.
Thank you, Bo. It's actually, our presentation it's a good segue from where Toby started, from single family and low rise multifamily to essentially mid and high rise building structures. And this is what Dextall does. We're a prefabricated panel organization that makes prefab unitized panels for mid and high rise building structures. So I'm going to get into some of the slides, and then we'll walk through what we do, and I'll give you some examples of our work as of recent. So most of these numbers are somewhat relevant to all the people who are listening, who are participating in this conversation. We know 40% of carbon emissions are contributed to buildings. If you look at the buildings, especially in the large metro areas like New York City, about 70% of carbon can be attributed to those mid and high rise structures. And so, we're estimating that 18 to 36 millions will be spent to decarbonize real estate in the next 20 years. So Dextall's mission is to accelerate decarbonization at the large scale. So when we look at the problem, we really look at globally, what can we do, not on one building, but what could we do potentially at hundreds of thousands of buildings and have a massive impact, by essentially dealing with building envelope enclosures. So real solution for real problem. As I mentioned, Dextall is accelerating decarbonization. Our prefabricated panels perform 40% better than energy efficiency than code requirements. And I'm taking New York City as an example in terms of the effective R value for the wall. The big issue in prefabrication modular buildings today is the initial cost, right? Everybody's talking about time and savings. On the future savings as you install the product, because you can install it faster, and everybody understands that the quality is better for products produced inside the factory rather than on a site. But Dextall took a slightly different approach. We said all these benefits are great as an add-on benefit. But initially, we have to be lower cost than on-site constructed walls in order to reach the mass market scale and essentially to accelerate the decarbonization. So currently, we're about 10 to 15% less expensive from the get-go compared to on-site build exterior walls. There's some images of our buildings that we've done in the past. And then essentially what we do is we enclose building envelope 80% faster with about 10 times less labor. So Dextall process is we're fully vertically integrated from design, fabrication, transportation, all the way to installation. So we believe that controlling this chain, that's what allows us to be price competitive and essentially, streamline the entire process. Our walls consist of non-combustible materials. So again, this product is not for wood constructed frame buildings. This product is geared towards buildings that use either steel or concrete framing materials. As of late, we're looking at some buildings that have mass timber structures where this product fits in very well as well. So the system itself is relatively simple. We use a perforated studs to cut down on thermal barriers, thermal bridging on the framing. Inside you have a mineral wool insulation. From the inside you have aluminum sheet metals. And then on the outside you have weather sheathing, which is water and air tight, but it's also vapor permeable, so it allows for the system to breathe to the outside. And our finishes are installed like a rain screen principle, so they're very much interchangeable. We can start with aluminum, go to ACM, cladding, thin brick, or as of late, we're starting to use solar BIPVs for opaque panels. So essentially replacing aluminum and making our exteriors work and produce energy. You can see we do some rigorous testings on our system because especially when you go in a mid and high-rise structures, the compliance is the key. These systems can get up to 15 pounds of water. In the image here, you see we're doing a dynamic water testing, which essentially uses the plane engine to create a storm effect. And then from the inside, there's a suction going on, which allows for any water to penetrate even smallest parts. Our system is fully gasketed, so once you start stacking up the panels, there's never a need to go back outside. So very different from a lot of other prefab companies where you still go outside and try to seal it with silicone backer rods and so forth. In our case, once the panel is installed, it's water and airtight. So once our system is installed around the building perimeter, the whole system is water and airtight. The big part of Dextall is really the software that we have, which is called Dextall Studio. And so essentially it replaces an outdated design and coordination processes. A lot of the people here are architects, designers. You know how it goes. You design a building, spend a lot of time doing this, all the way to the construction documents, and then GC gets involved. There's a price check, there's a bidding process. All of a sudden you realize it's over the budget. Goes back again, and it's a lot of times there's 2 or 3 reiterations of every single project. Where Dextall Studio essentially optimizes this part. We use our proprietary software that works directly with Revit, and I'll explain it to you in a second how does it essentially do. So architects can send us a building mass model with their intended design. Our system automatically reads off all the elevations, divides the envelope into the most optimal panel division, and basically for performance, cost, and waste factor, as all of you know, about 30+% of materials getting to the job site, of new materials getting to the job site, 30+% of them become a construction waste. Dextall panels can optimize the waste factor essentially to 0 because of the software that we're using, because we see the end of the supply chain, how the raw materials come in and how essentially we can optimize them to create the most optimal design. And then we can we can create various design options of what architects are looking for. There's a collaboration tool where essentially allows architects to go into our software, guide us, are you're doing the right thing, or there's some adjustments to be made. And then basically once the design is generated, then we bring it back to Revit, and architects can bring it back to Revit at the shop drawing level details. And so there's, you can see some of these examples here. So our AI essentially guides us towards the most optimal design. Not to say that we standardize the look of it. The looks can vary dramatically based on the design intent, but we can cut down this design and coordination process from 24 months that usually takes for mid and high-rise buildings to 2 weeks. And so here are some of the outputs. We provide a full detailed exterior Revit model, all the 2D drawings, elevations, plans, section details, whatever it's required for the project, technical specifications for project-specific specifications, all the submittals for project-specific and material-specific submittals, and the sustainability reports. We also analyze various options to reach the project's sustainability cost or performance results. A system recognizes the local codes and kind of understands like how to stay within the compliance mode. And then one of the biggest thing is we guarantee the price, right? Like that's where this vertical integration is really helpful for us to not only help architects design the buildings that look good, but actually design buildings that are executable, that can be constructed immediately. And then lastly, we automatically create a fabrication drawing set that feeds into directly our manufacturing, which generally for any other prefab companies, another 5 months lag time by the time they transfer shop drawings into fabrication drawings manually. So it's a whole system works like a one seamless process. I want to show you some reference projects. So we did this project in Queens, New York. It's I think it's a 9-story building. But what's important to understand here and kind of understand what sort of impact the prefabrication has towards buildings and building owners especially. So I actually cut and pasted this Excel spreadsheet detail here, but you can see our cost of material was essentially lower at the get-go, right? So the client paid less. Instead of 47 people that would work on the building exteriors for window cladding, insulation, framing, and so forth, only 6 people had to install the panels. Instead of 20 months, there was a 17 months overall construction schedule because they were able to speed up and pick up speed on the interior work as the building was wrapping up. And so not only there are savings from the initial cost, but reducing the timeline by 3 months, they were able to save about $200,000 on carry interest for the construction loan, and they were able to move in tenants faster as a 55 apartment building. And so total savings beyond the initial cost was about $944,000. So about $1 million on a $20 million project. So it's a 5% overall savings going prefab, and then having 6 people on the job site instead of 47. There's another project in Queens as well. So you can see how the panels are being launched, how they're being installed. And we wrapped it up, this building, in 6 weeks. And so we have a number of other projects, similar timeframes, and even larger structures. Now we're working on some 25 and 30-story buildings where we're significantly cutting down the cost. And again, once we're starting looking at the energy models of these buildings and understanding what sort of impact we can have as an organization, is really satisfying to understand that we can truly accelerate these decarbonization efforts. This is a very cool project. We're actually, the image on the left is an existing building. We are ripping off the existing facade, and in sections, we're replacing that with our panelized system. The only way they were able to achieve that, or they can actually do this, is by quickly enclosing the envelope, because the tenants will remain in place as the building is going up. or the building is up already as the panels are going up. And this is northern part of the Central Park in New York City. So it's the beginning of Harlem. There's another image of a building, and you can see all these buildings look sort of different, right? So there's a lot of creativity in terms of the design of what you can achieve with it. And this is a 25-story building that we're working on with L&M Partners in New York City. It's a project that's in Newark, New Jersey. It's a 25-story building, and we have plenty of others that we're currently in the design process, and especially all of our clients now are starting to utilize Dextall Studio to truly optimize their exteriors from the beginning and know the cost and basically streamline the design and coordination process. So I'll stop here.
Awesome. Thank you so much, Aurimas. That was a really great set of presentations. I love hearing how different people are responding to these issues of sustainability, efficiency, healthy materials, and like how these are all really intertwined. But there's just, so many different like exciting approaches happening. So it's really great to hear from you all, how you're kind of reacting to these, modern issues and to concerns of architects. I know we've had some questions coming into the Q&A, and I saw Tobe had been answering some of them. Feel free to add more questions as well. You can also raise your hand if you'd like to speak out loud. I can unmute you and you can ask your question there as well. I'm also going to go ahead and put up the poll now. If you would like to connect with any of our speakers, talk to them about current projects, just answer this poll and we will get you in touch with someone. There we go. All right, so I'll just leave that up for a few minutes. Let's see. Looks like Toby's typing in an answer about projects in the Northeast. But yeah, if you are looking for project recommendations or specific kind of questions, again, answering this poll is a great way to ensure that you can get in touch with someone after today's event. I actually have a question for you, Jessica, if you don't mind. I was just looking a bit more at some of the other brands that are in Cara Green's network. And I noticed that you have a mineral wool insulation company, Havelock Wool.
Yeah, it's sheep's wool, actually.
Sheep's wool. Okay, cool. Yeah, I just want to ask you a bit more about that. That's something that I hear from architects a lot these days, that people are really looking for healthier alternatives to insulation, and alternatives to spray foam, natural fibers. So if you have any experience working with these kinds of products, I think that's something I hear a lot about people looking into.
Yeah, and I appreciate the other two presentations from Dextall and Bamcor too, because I think they bring attention to the fact that the exterior of the building is something that often doesn't get looked at and is incredibly important to what happens on the inside. And Havelock insulation it's a great product because it is sheep's wool, and that sheep's wool fiber, it's like biomimicry. It's like thousands of years of learning that went into that fiber to protect that sheep from the elements. So what it actually does is it's like almost like the perfect fiber. It's not fiberglass, mineral wool. Those are not the perfect fiber. The actual structure of a sheep's wool fiber, if you look at it, is excellent for insulation and also for humidity regulation, because that's what it does to the sheep, in its environment. So it can actually retain humidity when it gets above a certain percentage, and then it'll release it when it goes below that percentage. So it's a humidity regulator within the wall cavity, which is fascinating of itself. It's very natural because it comes from these animals that need to be shorn, and it also permanently sequesters formaldehyde. So if you have wood in the cavity, all wood has some formaldehyde, but it's basically like an air filter in your wall. So Havelock wool is a really interesting product in that. And the problem with some of these new products is they may address this big problem, but are they commercially viable? Is the price point one that you can afford to do it? And people really just have to start incorporating kind of health and well-being, or operational efficiency in the case of some of what we've been talking about here, and see if that really makes sense. Another product that we carry is arbor wood, which is a thermally modified wood. It's chemically modified wood like Akoya and Kebony are sourced from one end of the globe, shipped to the other for treatment, and then shipped over to the US, and they have this huge carbon footprint. But Arbor wood is in, in Minnesota, in Duluth, Minnesota. So they're sourcing all their wood locally in the US, thermally modifying it, creating a product, decking, cladding product that has a 20-year warranty using heat. So, some of these techniques and some of these products that, they're kind of just getting to the market, they're really fascinating products. And, like these guys are showing, I mean, the building envelope is so important. And, it's just great to see two very different options using, that both have great stories. So I appreciate both Dextall and Bamcor for what they showed here today.
Yeah, totally. Me too. It was really cool to see how, like the different products and approaches can relate. Aurimas, I was, really interested in the software that you were showing. This is something that I had a brief period in my career where I was working at OMA and like designing skyscraper buildings. Most of the rest of the projects I worked on were more in the like single family high-end residential world. So I just can imagine during that time in my life that a tool like this would have saved me. I mean, as you mentioned, literally months of time and of design work. So that was really exciting for me to see. For folks who want to like get access to that tool and try that out I noticed there's like a form on your site, so you can just easily kind of request access there for that software.
Yeah, so actually we don't necessarily give the actual access to the architects. What we do is we use the software internally, similar to some of the architects might have worked with like Acelab or any other organizations where you upload the model. All we need is the upload of the building mass model. And then we basically take care from that on. And then there's a collaboration tool between architect and ourselves to essentially, have architect guide us to the final execution. We're not ready to fully release it to architects because what we've learned is that architects are generally super busy. There's another tool that they have to learn all of a sudden. And while this could be a great solution, the feedback from architects was that we should be the ones kind of producing the model and giving them back. But essentially, mid and high-rise building, shop drawing level, detail, exterior can be executed within 1 week.
Wow.
Which is sort of unheard of with a guaranteed price and executable design.
Yeah, truly unheard of. All right, I see a few more questions coming in. I'm also real quick just going to send a link for everyone in the chat for our event next week. Also free to register. Next week's event is a really interesting company who's tackling the handrail problem, which I am really excited about. I don't know if anyone else has related to having handrail issues, measurement issues, coordination issues, but that for me always ended up being a part of projects that took a long period of time and a lot of coordination. So excited for next week's event. All right, so I see a question came in about Dextall and where you build your panels. This person has projects in Austin, Dallas, Denver, and Seattle. So are those all within your area?
Currently, we build our panels in Europe, but all of the panels that we build are shipped to the United States. We're predominantly concentrating on the Northeast, but we can ship it anywhere around the country.
Cool, good to know.
And we work with local certified installers to essentially install this project.
Okay, great. All right, so that one's answered live. And then I see this question for Toby. Looks like you're typing an answer and it looks a bit complex, so I'll just let you answer that one. But yeah, if anyone else has any other questions, feel free to send them in now. And again, that poll is still up for anyone who would like to register. I've also sent 2 links, both for an Acelab info session and for a virtual event next week. Yeah, so that should be it from me.
Thank you, Bo.
Yeah, thank you, everyone. I really enjoyed hearing everyone's presentations today. It's always so fun to do these, groups. I think that, it really adds something to be able to hear from like multiple people back to back, and to be able to kind of like relate the ways that they're, tackling all these issues. So yeah, I've really enjoyed it. Thank you everyone in our audience for joining today. It was really great to see everyone and to have so much engagement and interest. So thank you for asking questions and for showing up. And yeah, we hope to see you at one of our upcoming events. We've got quite a few coming up in the next few weeks. So excited to continue hosting these for you all. All right. Thank you, Toby. Thank you, Aurimas. Thank you, Jessica.
Thank you.
Thank you.
Okay,
Bye-bye.
have a good one. Bye.